Right. In a number of cases, you'll be given certain information and asked to provide equations of straight lines. Okay. So these we were given the equations and we had to rearrange them. Which format do we rearrange them to be? Mx plus c or whatever letters you use. But here they make it different information. So the two bits of information we always want to know is what's the gradient and what's the y-intercept. Because we know that if we have those two pieces of information, then we can put them in place of the m and the c, and we've got our equation. Alright, so this first example, we've been given a gradient and a point on the line. So we have to say to ourselves, how does that help us? Well, straight away, oh shush now, because they've told us that the gradient is 2, I know my equation is going to start off as y equals what? 2x plus c. Yes? That was pretty easy. So because they told us the gradient is 2, I know that the gradient always goes in front of the x value, the x variable. So I know my gradient is going to be something like y equals 2x plus whatever. Okay? Now, they've told us it goes through this coordinate. What does this first number tell us? The value of which?
Y.
X. X. And this tells us the value of y. Now, these values here change, yes, depending on what the rule is. But for this particular equation, one of my values of x is 1 and its corresponding value is 3. Which means that I can stick those two values in place of the x and the y. So I could say, oh, let me do some colour coding. So I would say that 3 is equal to 2 lots of 1 plus 3. Does that make sense? So we know it's y equals 2x plus c because the gradient was 2. We're then sticking in the value of x is 1 and y is 3 because we know it goes through that coordinate. Now we can do some rearranging. So 3 is equal to 2 lots of 1 is obviously just 2. And then rearranging that, c would be 1. You all happy with that? Yes. Let's just take 2 from both sides. Yes, subtract 2 from both sides. So that means that if c was 1, then this is going to go back into this original thing up here. So our final answer is y equals 2x plus 1. Done. Okay? We are awesome. Okay, so next one, again, we've been given a gradient and a coordinate. So, Jada, how am I going to start this off? Yeah, so what will I write? Lovely, jubbly. Layla, what will I do now? Not yet. So what am I going to, I'm looking at my information here, I know it goes through this coordinate, 4, -2.
Oh.
Next, why do I start with -2? Perfect. So -2 equals -4/5. Nice, nice, nice. Plus C. Okay, we're happy with that? Beautiful work. Love it, love it, love it. Now this isn't as nice because we've got fractions involved. Okay, so you will have your caps available to you, but let's pretend that we haven't. Sure, let's pretend we haven't. So 4 whole ones is 4 over 1. Yes. How do we multiply fractions together? No. No, don't change the denominator. Just multiply top, bottom, bottom. Okay, we've got to remember that. So it's -2 equals -16/5. And then C, what do we do to get C on its own?
Minus 2 plus.
Oh, yeah, you're going to add 16 over 5 to both sides, yes? So it's going to be negative 2 plus 16 over 5. Oh, goodness. So, this has got a denominator of 5, so we want the first value to have a denominator of 5. So what do we have to do? We have to multiply both top and bottom by 5. So we've got negative 10 over 5 plus 16 over 5, which is
Negative 3.2.
so negative 10 over 5 plus 16 over 5 is 6 over 5. Because it's negative 10, yeah? So there's our fancy pants value for C, and then that's going to go back into the original. So it's going to be y equals negative 4/5 x excuse me, plus 6 over 5. So this time, we've just been told 2 coordinates on the line. Okay? So we have to think to ourselves, right, the 2 pieces of information we need to know are the gradient and the y-intercept. Now, am I able to find the gradient if I know 2 coordinates on the line? Yes. How do I do that?
Now.
Rise over run. Okay, rise over run. What? Rise over run would be what? How do we know the rise? How do we know the run?
Rise is fixed.
X is the run. Y over X.
Yeah, y over x, I think is what people were saying. There was a few differences of it.
Oh yeah, y1 plus y.
Almost not plus.
Yeah, times y minus. That. I was close.
Alright, so if you remember way back yonder, we initially looked at the gradients when we were given 2 points. Remember we called this x1, y1 and x2, y2? Like it was 100 years ago
That's
now.
what I would say.
I know, my darling. I didn't say you were wrong. Well, other than the fact that you said plus and then something else, multiply, and subtract it. So, remember, it doesn't matter which order you do them as long as you stick with the same coordinate to start with. So I'm going to do 1 subtract 4 over 5 subtract 8. Okay? You could have equally done 4 subtract 1 over 8 subtract 5. Both would have given you the same answer, eventually. So what's 1 subtract 4? Negative 3. And what's 5 subtract 8? Negative 3. What's negative 3 divided by negative 3? 1. So my gradient is 1. Same thing here, but obviously they were both positive.
Wow.
Amazing. Maths is amazing. No, that's right. They're my 2 different options.
Yeah.
No, it doesn't matter. You get the same answer then. Yes, Titania?
So wait, what one is the gradient?
Yes, so we just found the gradient. So the gradient is 1. And so now we know the gradient, we go back to doing what we did just up here. Yes? So we know that our equation, Emily, starts with y equals, what do I write here? It's equally just x. Yeah? You happy with that? And now we're going to choose one of these points. I will tell you now it does not matter which point you choose. Okay, so if you like the look of point A, you choose point A. If you like the look of B better, you choose point B. Either one will get you the value of C. Okay, I will do both to show you that it doesn't matter. So I'm going to choose point A first of all. Jodie? Because M is 1, sweetheart. If you want to and you're working like 1, I don't mind, but don't write it your final answer. Okay? So I'm going to choose point A, so I'm going to say that 4 is equal to 8 plus C. So I'm going to subtract 4 from both sides and I get C is negative 4. Choosing coordinate B, I've got 1 is equal to 5 plus c. Subtract 5 from both sides, I get negative 4 is equal to c. Luckily it's the same. That's what I told you it was too. And now I'm going to put that value back to the original. So I've got y equals x subtract 4. Okay, as I said, don't write the one part when we're doing these questions. Okay, so hopefully you all got negative 1/3 as your gradient. Okay, so we've got to remember that we're subtracting our values, and when we subtract a negative, it ends up adding x. So I've got I've got negative 1/3 as my gradient, so I know my equation starts as y equals negative 1/3 x plus c. I'm going to choose one of my coordinates. I don't know, which one should we choose?
No, A.
I'll do both. I'll do both. Okay, I'll choose the coordinate m. So I'm going to have negative 2, negative 2 equals negative 1/3 multiplied by negative 1 plus c. Negative 1/3 multiplied by negative 1 becomes positive. Alright. So I didn't say you were wrong. Negative 2 subtract a third is c. And so,
Negative 7. What is that?
So we've got, well, we make it common denominator. So this becomes negative 6 over 3, subtract 1 over 3. Yes, which is negative 7 over 3. No, you don't. When you multiply the fractions, you don't change it. Well, we were multiplying a minute ago when you said change the denominator. And now we're adding or subtracting. Now, Natalia, are you ready for your question? Okay.
How does 2 over 1 become 6 over 3?
Because I've made the denominator 3.
Okay.
You hear me, sister? Right. Did anyone choose point N that would like me to do that?
Well, I got it wrong. N is irrelevant.
Oh. That's a bit hard.
I don't think N appreciated that.
No, I don't either.
Well, no one chose it.
So we've got. Oh.
My court does not want N.
So there we go. We've got our final. We've got our final. Our final equation: y equals negative 1/3 x minus 7 over 3. Okay, next one. So this has a gradient of negative 1/2 and cut the y-axis at 4. So we've got our gradient. So we can start off our equation as evaluate what?
Y equals plus 4.
Oh, check you out. You went straight for it. How do you know it was plus 4?
That's the Y.
Nice. As Eve said, it says it cuts the y-axis at 4. We know that cutting the y-axis is exactly what we mean by the constant c, yes? And so that's why we can put that value straight away in there. Okay? So our equation straight away is y equals negative 1/2 x plus 4. Now we need to find the equation of a line that's parallel to a line with a slope 3 and passes through the point negative 1, negative 2. Alright, so Cassidy, how am I going to start off? Can I tell what the gradient is? Are you sure? Why can't you? Well, it's not actually a slope 3. It's parallel to something with a slope 3. Alright, so what do we know about parallel lines? Anyone remember, Lara, even with your bad toe? Do you remember stuff that's
It's my whole foot.
about your whole foot?
Well, there's parallel and then there's another one. Perpendicular. And one of them is equivalent to its opposite. like -3.
Okay.
That's
That's what I
Parallel
remember.
lines. What do we know? Let's visualize a parallel line.
Is it when you go like 3/1 and then you flip it so it's 1/3? Okay, then I don't know.
So, Alexis.
I know
Okay. Just FYI, I know I'm looking at it, but I'm trying to also help the video option. They can't see you. What do we know about parallel lines?
They're equal like length apart from each other and you go like
Yeah, and what does that mean is special about them? They have the same gradient.
that was Amelia.
Thank you, Marie. Anybody just put anything in wrong? I
had my hand up.
Alright, so we know that parallel lines have the same gradient. So, Cassidy, what's the gradient of this line? What's the gradient of this line? 3. Remember, slope is another word for gradient. I know, sweetheart, you told me it was 3 before, but I'm not convinced you knew why it was 3. I think you just saw the word slope was 3. Is that right? Is that fair assessment of the situation? Alright, so I know my equation is going to start as y equals 3x plus c. And then we're going to do what we did before. We're going to stick in the coordinate -2, -1, -2. So we say -2 equals 3 dots to -1 plus c. Adding 3 to both sides gives us a value of c is 1. So our equation is y equals 3x plus 1. Yes. Let's do it. 2 minutes. Right. Now we need to find one that's perpendicular
Oh, I know this
to
one.
a line with -3. So, Lara, if I know my gradient is... Shh. Your name's not Lara. How do I know what my gradient will be?
It will be there's a specific word.
Just tell me what it is.
Reciprocal!
Yes, good girl. Almost. Negative reciprocal. It's negative reciprocal. Let's try to shout out. So what's my actual gradient going to be?
So the first gradient is -3/1.
Okay.
So the second gradient would be 3/1, or would it be 1/3?
You tell me. You're trying to find the reciprocal.
1/3.
Good girl. Alright, so the gradient that we're interested in is a positive 1/3 gradient, because that is the negative reciprocal of -3, and that's what perpendicular gradients are all about. So we know it's going to be y equals 1/3 x plus c, and then we're going to stick our values in. So -1 equals 1/3 multiplied by 4. -1 equals 4/3 plus c. So that's -1 minus 4/3 plus c, which is -7/3. Oh, what am I doing here? Let's find it all hard. So my equation is y equals 1/3 x minus 7/3.